Hello and welcome to SigmaXL video tutorials. This is a brief getting started tutorial video for users who are new to DiscoverSim. So what is DiscoverSim and what does it do? DiscoverSim enables you to quantify your risk through Monte Carlo simulation and minimize your risk with global optimization. Business decisions are often based on assumptions with a single point value estimate or an average, resulting in unexpected outcomes. DiscoverSim allows you to model the uncertainty of your inputs so that you know what to expect in your outputs. DiscoverSim is an Excel add-in for Monte Carlo simulation and optimization. It's easy to use with Six Sigma language. Specify inputs, or X's, and outputs, Y's. It's ideal for DFSS, risk, and project management. It's powerful. 53 continuous and 10 discrete distributions, distribution fitting with automatic best fit, and specify correlation between inputs. It's fast. Accelerated calculation with Excel spreadsheet interpreter. Identify important X's with sensitivity analysis based on correlation or stepwise regression. Includes quadratic terms. Discover solutions to difficult problems with global optimization. Optimize statistics such as DPM or PPK and allow for constraints. DiscoverSim is also bundled with SigmaXL for statistical and graphical analysis. DiscoverSim utilizes the y equals f of x model, where y denotes a key process output response and x denotes a key process input. An input distribution is stochastic and includes random variation. It can be continuous or discrete. The most common continuous distribution is the normal distribution, with parameters mean and standard deviation. An input control is set to a constant value, but it can be varied like the temperature control knob on a thermostat, and it's used for optimization. An input control can be continuous or discrete. Every DiscoverSim model requires at least one input and one output. The output cell must contain an Excel formula that is a function of the inputs and references the cell address of the inputs or intermediate calculations including the inputs. The formula can be linear or nonlinear and include Excel functions. The formula can reference other sheets within the workbook but should not reference other workbooks. The DiscoverSim Excel formula interpreter is used to dramatically accelerate the speed of calculations during simulation or optimization. The y equals f of x equation should be based on theory, process knowledge, or the prediction formula of a designed experiment or regression analysis. In Design for Six Sigma, or DFSS, this is referred to as the transfer function. This prediction equation should be validated prior to use in DiscoverSim. As the eminent statistician George Box said, all models are wrong, some are useful. So while the model does not have to be exact, it should be a reasonable approximation of reality. The results of a DiscoverSim analysis should also be validated with further experimentation or use of prototypes. This diagram illustrates a simple Monte Carlo simulation using DiscoverSim with three different input distributions, or X's, also known as assumptions. A random draw is performed from each input distribution, y is calculated, and the process is repeated 10,000 times. The histogram and descriptive statistics show the simulation results. While not shown here, requirements, specification limits, can easily be added to y to obtain probability of nonconformance. Notice that even though input distributions A2 and A3 are not normal, the distribution for the total is normal. This is due to the central limit theorem. Of course, this will not always be the case when performing a Monte Carlo simulation. The areas of application for Monte Carlo simulation are very wide, including DFSS, tolerance design, project management, and risk management, with common use in engineering, finance, telecommunications, and oil and gas exploration. To begin our example, click DiscoverSim, Help, Case Studies. Open the file DemaicProjectDuration.xlsx. This is an example model of a Six Sigma project with 5 phases: define, measure, analyze, improve, and control. We're interested in estimating the total project duration in days. Management requires that the project be completed in 120 days. We will model the duration simply as total duration equals define plus measure plus analyze plus improve plus control. We will model each phase using a triangular distribution, which is popular when data or theory are not available to estimate or identify the distribution type and parameter values. The minimum, the mode, which is the most likely value, and the maximum durations were estimated by the Six Sigma project team based on their experience. Click cell C4 beside Define. We're going to specify our first input distribution. To do this, click DiscoverSim, Input Distribution. Input number is provided for reference purposes only. Input name is the cell address by default. Enter a name to describe the input, or you can click the cell reference button and specify the cell containing the input name. Input cell color can be modified by clicking on cell address. Select from Common Continuous, Advanced Continuous, Discrete, or SIP distributions. A brief description of the selected distribution is given in the dialog. Click View Distribution Formulas for distribution formula details, probability density function, and cumulative distribution function. These distribution formulas are also given in the appendix of the DiscoverSim workbook. If distribution fitting has been performed, the Select Stored Distribution Fit option will be available for selection of variable names and stored distribution. Parameter values can be manually entered, or click the cell reference and specify the cell containing the parameter value. Click Update Chart after changing the parameter values to view distribution. Check Truncate and enter truncation minimum and/or maximum values to produce a truncated distribution. Blank entries will be treated as negative infinity for minimum and positive infinity for maximum. Include and specified input correlations is checked by default to allow correlations to be specified for this input. The first thing I'm going to do is assign a name to the input using our cell reference function. Click on the cell reference button beside the name and select the cell that contains the name. In this case, cell B4. Click OK. The name of this input is now specified as Define. Note that you can also specify a name manually by typing it in. Select Triangular Distribution. As mentioned, our minimums, modes, and maximums have been estimated for each phase by the Six Sigma project team, and they're referenced in our worksheet. We'll use the cell reference function to assign our minimum, mode, and maximum to this input. Click the cell reference button beside minimum. Select the minimum referenced at cell F4 and click OK. Do the same for mode and maximum. Click Update Chart to see a preview of the updated chart with these values. Click OK. You can hover the cursor over the new input at cell C4 to view DiscoverSim's graphical comment showing the distribution and parameter values. Now, to save time, we're going to use DiscoverSim's copy and paste functions to automatically populate the remainder of our input distributions. With our input selected at cell C4, click DiscoverSim's Copy Cell button. Now select cell C5 through C8. Click DiscoverSim's Paste Cell button. Do not use Excel's copy and paste functions. They will not work. Verify the input comments appear for each of our new inputs by hovering your mouse over each cell. Our output response will be added to cell C11. Note that this cell already contains the Excel formula, sum of C4 through C8, the sum of all 5 inputs. Click the Output Response button. Output number is provided for reference purposes. Output name is the cell address by default. Enter a name to describe the output, or click the cell reference and specify the cell containing the output name. Output cell color can be modified by clicking on cell address. Default colors can be changed in Help, DiscoverSim options. Function displays the output cell equation. The equation can also be changed in this field. LSL is the lower specification limit. USL is the upper specification limit for the output. Entry is optional for simulation but required to produce process capability indices. LSL and USL are also used as the lower and upper bounds for the desirability function in multiple response optimization. Specification limits can be manually entered or click the cell reference and specify the cell containing the specification value. For our model's output response, enter total as the output name. Enter the upper specification limit, USL, as 120 or specify cell reference C13. Optimization settings are not used in this example, since this is strictly a simulation. Click OK and hover the cursor on cell C11 to view the DiscoverSim output information. Select DiscoverSim, Run Simulation. Click Report Options Sensitivity Analysis to display all report options. The replications value sets the number of simulation replications. Seed is set to clock by default, so that the starting seed of random number generation will be different with each run. If you want the simulation results to match every time, for example in a classroom setting where you want all students to obtain the same results, select Value and enter an integer number. Note that the results of a fixed seed for 32-bit Excel will be slightly different than for 64-bit Excel. Select Monte Carlo Random for full randomization. Latin hypercube sampling is less random than Monte Carlo, but enables more accurate simulations with fewer replications. Accelerated mode uses DiscoverSim's Excel formula interpreter to dramatically increase the speed of calculations for rapid simulation. If unchecked, the calculations are performed using native Excel. The interpreter supports the majority of all Excel numeric functions. For more details, see the appendix of the DiscoverSim workbook. If the DiscoverSim interpreter sees a function that it does not support, you will be prompted to use Excel's native mode. Run validation using native Excel runs a validation test to compare accelerated mode versus native Excel. Each output is assessed by comparing the simulation means. If the worst case relative difference is less than or equal to 1e minus 10%, the test passes and the status is success. Check independence, ignore correlations to run the simulation with all inputs independent of each other for zero correlation. This is recommended if you're running a sensitivity regression analysis. However, it is not necessary here because we did not specify correlations in the model. Check Store Simulation Data in Worksheet to store simulation input and output data in a worksheet. The number of simulation replicates or runs must not exceed the maximum number of rows permitted in the version of Excel that you're using, and the total number of inputs and outputs cannot exceed the maximum number of columns permitted by Excel. Histograms, probability plots, and process capability report are checked by default for display in the simulation report. These graphs and tables apply only to the output response data. A report will be produced for each output. Descriptive statistics are always reported. They include confidence intervals for mean, standard deviation, and median with a default 95% level. The confidence level can be modified. Descriptive statistics also include the normality tests, Anderson-Darling, skewness, and kurtosis. Histograms will display a normal curve and specification limits if applicable. Probability plots are normal probability plots, but only display a small sample, 500, of the data to speed up the report display. Check sensitivity charts to view vertical bar charts of correlation coefficients, sorted Spearman rank correlation for output versus each input. This sort is by magnitude, with the chart x-axis range being -1 to +1. We will not be demonstrating scatter plots, correlation matrix, or sensitivity regression in this video. Select seed value and enter 12 in order to replicate the simulation results in this video. Click Run. The DiscoverSim output report shows a histogram, descriptive statistics, and process capability indices. From the histogram and capability report, we see that the total project duration should easily meet the requirement of 120 days, assuming that our model is valid. The likelihood of failure based on the actual simulation performance is approximately 0.01%. A summary of the model input distributions, parameters, and output response is also given in the simulation report. Click on the sensitivity correlation sheet. If we needed to improve the performance, the sensitivity charts would guide us where to focus our efforts. Here we can see the control phase is the dominant input factor affecting total duration, followed by improve and measure. The results in this simple example are intuitively obvious from the input values, but keep in mind that a real model will likely be considerably more complex, with sensitivity analysis results identifying important factors that one might not have expected. This concludes the DiscoverSim Getting Started tutorial video. For more videos, visit www.sigmaxl.com or join us on YouTube. Thank you for watching.